Section 17 is about quadratic graphs. Now, this question up on the screen there is something I've made up. You've not asked to plot the graph of y equals x squared, and it's going to take an awful long time for me to do each one of these questions. So what I've done is prepared the table and also the axes. So this is the y-axis, as you know. This is the x-axis. Now, what I'm going to do is just talk you through this little bit here. And there is a question 4 very similar to this, which is on the other page, and I didn't feel that question 4 was appropriate unless you've had a chance to see what this actual equation was. So let's look at y equals x squared. In other words, you substitute values into the x just like it was a linear equation. You shove it in where the x goes, you calculate what you have to calculate, create the coordinates and plot them. So let me just talk to you through this. When x is minus 3, put minus 3 where the x is, like I've done just here. Then you square it. Well, minus 3 times minus 3 is 9. So I've created the points minus 3, 9. There it is in blue. Minus 3 on the x and 9. Now we can plot it. Minus 3 and 9 up is right there. Next one, you plug minus 2 into there. So minus 2 squared is 4. So I've created the coordinates minus 2 on the x, 4 for the y. So minus 2, 4 is there. Next one, you plug minus 1 into the x. Minus 1 squared is minus 1 times minus 1, which is 1. So I've created the points minus 1, 1. That's there. Clearly, if you put 0 in there, the answer is 0, because nothing times nothing is nothing. And then we just carry on working in the normal way. 1 squared is 1, 2 squared is 4, 3 squared is 9. So we plot the points 1, 1, 2, 4, 3, 9. You may have seen some of these in Key Stage 3 actually, but now we've got to know it for real for GCSE. And that is clearly not a straight line. I've not made a mistake. It is a beautiful curve. Let me try and draw this freehand. Do the best I can. So I'm starting from about here. Drawing that little line. You must not, under any circumstances, use a ruler. If you use a ruler, you're implying there's a linear relationship, and you're trying to cheat. So that is the equation of that line right there. Okay, y equals x squared. It's absolutely beautiful. If you look at this coordinate here, it's clearly 0, 0, isn't it? Well, it should have passed through 0, 0. Look, the point is there, and this is called the minimum. How they call it here? Yeah, they call it the minimum point. In other words, the graph of y equals x squared will keep flying off in the positive direction there and keep flying off in this direction here, but it will not drop below the point 0, 0. Therefore, the coordinate 0, 0 is called the minimum point. That's something you need to learn. Here's another thing you need to learn. Look at that. Look at the y-axis. It cuts the graph exactly in half. So therefore, the y-axis behaves as a line of symmetry for that graph. So I'm going to write it down here. The y-axis has equation, you should know this, but I'm going to tell you anyway, has equation x equals 0. Remember, all the x lines go that way, oops, and all the y lines go across that way. Alright, you've heard me say this before. So that's just to revise now. That will be the equation x equals 1. This will be the equation x equals 2. Therefore, this must be the equation x equals 0. So the y-axis has equation x equals 0 and is the line of symmetry for the equation y equals x squared. Alright, so minimum point is a new thing you need to learn, and the fact that a lot of these graphs, well, all of them will have lines of symmetry. Alright, so that's that one. It's a homemade question. This is what should have been question 1 really, but it wasn't in the book. So here's question 4. Again, I've calculated the coordinates to save time. Let's see how I colour coded this little lot. Right, so we're plotting black, aren't we? Right, y equals minus x squared is really what question 4 is about. I've done the calculations here. So be very, very careful. You plug a minus 3 in there. This means you take the x value, minus 3, square it, and then stick a minus in front of it. Alright, so that's why I put a bracket there. You take your minus 3 and square it, which is 9. Now put a minus in front of it, minus 9. So we get minus 3 for the x, minus 9 for the corresponding y value. That's why the coordinates is going to be minus 3, minus 9. So I better just extend this graph a little bit, I think. So we go further. So minus 4, minus 6, minus 8, minus 10. That should be 5. So here we go. Y-axis, x-axis. So minus 3, minus 9 is here. Right there. And then you put the negative 2 in the x value. So we say minus 2 squared is 4. Then put a minus in front of it. It's minus x squared. So we get minus 4. So you get x is minus 2, y is minus 4. So minus 2, minus 4. Minus 2, minus 4. In the same way, put the minus 1 in there. Minus 1 squared is 1. Put a minus in front of it. So you get minus 1. So you get the coordinate minus 1 and minus 1. And here it is right here. Right in the way of my minus 1, but never mind. 0, 0 again. And then if I carry on plotting in the normal way, you can see the coordinates there yourself. 3 minus 9. Oops. 3 minus 9 is going to be here. So I reckon that coordinate's in the wrong place. My eyes skipped, sorry. So minus 3 minus 9 is right there. There it is. And look at that beautiful curve. Difficult to draw by hand. Certainly difficult on the screen, so let me just try that. So take it up to 0, 0, climb back down slowly, and that'll do. So this is the graph of y equals minus x squared. Now here's the point 0, 0 again, alright? Now the graph will continue to shoot down this way and down this way. It will never rise above the point 0, 0. Therefore, this is called the maximum point, as opposed to on the previous page where we looked at the minimum point. Okay, so here it won't get any bigger than that. So the maximum point is the point 0, 0, and once again it has the same line of symmetry, the y-axis, or the line of equation x equals 0. So this will be the line of symmetry. And it's the equation x equals 0. Is that right? Line of symmetry of the equation. Let me fully write it. Y equals minus x squared is x equals 0. Alright, it's fully done. And let me just try another question from scratch this time. I want to look at maybe question 5. I don't like the way they set out the tables. A lot of textbooks do that. I don't like it. I prefer to do my way. I'm going to plot the equation y equals x squared minus 2x. Alright, so it's a bit more complicated. So, and I want to go from, they say, minus 3 to 3. So these are my x values. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Do that, it looks pretty. And that, I've now got to work out my y values now. So y equals x squared minus 2 times x. Now let's see how much space I need for this. I'm guessing about that, and extend over here as well. So here I'm going to have the coordinates themselves. And what I may do is just like pause the video, do a couple of calculations, pause the video, and then just give you the answers. So here's the first one. X squared, so you take your minus 3, you square it, then you take away 2 lots of your minus 3. Please look at my wording. Minus 3, square it, then minus 2 times minus 3. Well, you're allowed to use a calculator in this unit, but I won't. Minus 3 times minus 3 is 9. Minus 2 times minus 3 is 6, positive 6. 9 plus 6 is 15. So I've created the coordinate minus 3, comma 15. Alright, that's the first one done. I'll do another one or two, and then I maybe pause just to fill up the rest. Here we go, minus 2 squared, that's x squared. Take away 2 lots of minus 2. Let's work it out. Minus 2 times minus 2 is 4. Minus 2 times minus 2 again is plus 4. 4 plus 4 is 8. I've created the coordinate minus 2 and positive 8. Let's just take one down the bottom here. Just do this one. I've got 3, let's put it in the brackets so it's consistent. 3 squared, take away 2 lots of 3. Okay. Well, 3 squared is 9. Minus 2 times 3 is minus 6. So 9 take away 6 is going to be 3. So I've created the coordinate 3, 3. Is that alright? So what I'm going to do is pause there and fill up the rest and get back to you. Okay, so that's the rest of the points that I've done for you, this lot here. I didn't need a machine. In fact, back in the old scheme, this would have been a non-calculator part of the syllabus, so you'd have to do it without a machine, and sometimes better not to, because if you get confused with brackets and you fail to put in a bracket, you're going to miscalculate, and then you believe what you've actually got in your calculator and get it wrong. So anyway, I've created the coordinate minus 3, 15. Let's just plot that quickly. Minus 3 up the screen, 15 is there. Minus 2, 8. Minus 2, 10, come back 2. That's 8. And then we've got minus 1, 3. There. 0, 0 again. Then we've got 1 minus 1. There it is. We've got 2, 0. So we're climbing back up now. And we've got 3, 3. Now, look. Let me just draw that in freehand as best as I can. Let's pull up my sleeves for this one. Looks tricky. So have a bit of a run up down to that. Hit my minimum point and come back up. I missed it, never mind. Now I know if we had more x coordinates here in the positive direction, the graph would just keep going off the screen there. It doesn't matter. You can see the line of symmetry is right through the middle there, and I'm going to put it in so you can see it. Not to confuse you, but I want you to absolutely see this. It doesn't matter that the graph, that's not very good, I don't like colour. Let's go with something a little bit darker than that. Let's try this. Got this orangey little affair here. Right. Put it about there. Look at that. Now that is the equation x equals 1, and it cuts the graph in half. Don't tell me, sir, well look, there's more stuff on the left than on the right. I know that, but as I said, if you keep drawing up there in that direction, as my pen's now gone off the screen, if we did, for example, had an x value of 4 and calculated the y value, that would in fact carry on going up there. Now, have you noticed that the line of symmetry of equation x equals 1 cuts through the minimum point? So let me just label that as a minimum point. That would be brilliant. So that is the minimum point. I know it's the minimum point because the graph will not go any lower than that. So it's a minimum. And that's going to be 0. No, it's going to be 1 minus 1, sorry. I didn't see it, I covered it. So that coordinate there is 1 minus 1, right? 1 along, 1 down, but we can't really see it because we've drawn over it. And this will be the line of symmetry of the equation of y equals, there it is, x squared minus 2x. And of course this is the equation of the line y equals x squared minus 2x, or rather it's the graph of the line of equation y equals x squared minus 2x. Let's just pretty that up a little bit. X squared, there you go, that's that. That's fully loaded. I've not even looked at the question yet, so I better just do that. This is question 5. Yeah, I've done all that. Yes, 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 yes. What is the minimum point on the graph? Well, that's all they ask, really. The minimum point is 1 minus 1. They could have asked us about the line of symmetry, which is clearly the line x equals 1. I'm going to stop there and do one more in a separate video, which is a little bit long, but I will do it anyway, because it asks some other good questions that have not come up yet. So I'm going to stop now, and you've got plenty to think about.